The morning of March 7th, 1943, Technical Sergeant James Kovacs watched his M2 Brownings barrel glow dull red through the pre-dawn darkness at Bougainville. The weapon had been firing for 2 minutes and 14 seconds, pouring half-inch projectiles into a Japanese banzai charge that showed no signs of stopping. The technical manual sitting in his ammunition bunker, now spattered with mud and blood, stated in bold letters that sustained fire exceeding 2 minutes would result in barrel failure. Kovacs knew this. Every machine gunner in the Pacific knew this. The problem was that the Japanese soldiers scrambling up the ridge toward his position didn't care about American technical manuals. They cared about reaching Henderson Ridge before dawn, and Kovacs's gun was the only thing stopping them. At 2 minutes and 30 seconds, the barrel temperature had climbed past 1100 degrees Fahrenheit. The steel was losing structural integrity with every round. At 2 minutes and 45 seconds, rounds began keyholing, tumbling sideways through the air instead of flying true. At 3 minutes exactly, Kovacs released the trigger, not because the attack had stopped, but because continuing to fire meant transforming his best defensive weapon into a fractured tube of useless metal that might send shrapnel back into his own face. The Japanese used those 30 seconds of silence to advance another 40 yards. By the time Kovacs and his loader executed the barrel change procedure, working with the desperate speed that comes from hearing enemy soldiers getting closer in the darkness, the assault force had cut the distance to his position by half. They resumed firing with a cooled barrel, but the tactical mathematics had shifted. The 40 yards they'd surrendered during the barrel change would cost 3 Marines their lives before the sun came up. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This scene repeated itself across every defensive position in the Pacific Theater, where American forces relied on the M2 Browning 50 caliber machine gun. The weapon that soldiers called Ma-Deuce had earned its reputation through devastating firepower. Each round carried enough kinetic energy to punch through engine blocks at 500 yards, tear apart light armor, and send a half-inch diameter projectile screaming downrange at 2,910 feet per second. When John Moses Browning finalized the design in 1921, he created what military historians still call the most successful heavy machine gun in history. The psychological impact alone was worth its weight in gold. Japanese soldiers called it the woodpecker of death because of its distinctive firing rhythm, a mechanical hammer that announced American positions with authority and turned jungle approaches into killing zones. But the M2 carried a fatal limitation that every machine gunner learned to fear, and that limitation wasn't ammunition supply or mechanical reliability. It was heat. Pure thermodynamic reality that could turn your most powerful weapon into dead weight at the exact moment when failure meant death. The problem wasn't theoretical, it was mathematical, predictable, and absolutely merciless. Every time the M2's firing pin struck a primer, it ignited 240 grains of smokeless powder that generated approximately 18,000 foot-pounds of energy. Most of that energy propelled the bullet forward at velocities that made the weapon devastating against aircraft, vehicles, and fortified positions. But roughly 30% of that explosive force converted directly into thermal energy, heat that the barrel had no choice but to absorb. Fire 100 rounds in rapid succession, and you were pumping 540,000 foot-pounds of thermal energy into a steel tube that weighed just 26 pounds. The math was simple and brutal. After 2 minutes of sustained fire, the barrel temperature climbed past 800 degrees Fahrenheit. Push it to 3 minutes, and you were flirting with 1100 degrees. At 1200 degrees Fahrenheit, the barrel steel began to lose its structural integrity in ways that ranged from inconvenient to catastrophic. The Army Ordnance Department knew this, of course. The technical manual issued to every M2 crew included explicit warnings printed in bold letters. Sustained fire exceeding 2 minutes will result in barrel failure. The consequences of ignoring this warning varied, but none of them were good. Best case scenario, the barrel warped slightly from thermal stress, and your accuracy deteriorated. Bullets started tumbling instead of flying true. Tracers drew weird spiraling paths through the air, and your effective range dropped from 800 yards to maybe 300. Worst case, the barrel actually ruptured, sending steel fragments back toward the gun crew and rendering the weapon permanently disabled. Mid-range on the disaster scale, the headspace, that critical gap between the bolt face and the barrel, would expand from thermal deformation, causing rounds to detonate prematurely in the chamber. Gunsmiths called this a cook-off, and it could transform a controlled weapon into an uncontrolled one with terrifying speed. Standard doctrine addressed this limitation head-on. Every M2 position required a spare barrel and a crew trained in the barrel change procedure. The theory was elegant. Swap the barrel every 90 seconds, let the hot one cool for 20 minutes, and you could theoretically maintain fire indefinitely. The barrel change itself took about 30 to 45 seconds if your crew was good, maybe 60 seconds if you were working in the dark or under fire. The Army even issued asbestos gloves specifically for handling hot barrels, though most crews found them too bulky and just used rags or their uniform sleeves, accepting minor burns as the price of speed. But all of this assumed one critical thing. You had time to stop shooting. You had those 30 to 60 seconds when no enemy soldiers were rushing your position, no aircraft were strafing your line, no immediate threat required continuous fire to survive. In training exercises back at Camp Pendleton or Fort Benning, that assumption held true. On Guadalcanal in November 1942, on Bougainville in March 1943, and across dozens of other defensive positions where the Empire of Japan tested American resolve, that assumption collapsed completely. The tactical reality was straightforward and unforgiving. Japanese assault doctrine relied on overwhelming defensive positions through sustained pressure and numerical superiority. They would mass infantry in the tree line, sometimes 200 to 300 soldiers preparing for a single assault, then launch human wave. Attacks designed to either break through American lines or die trying. The waves came in succession, spaced maybe 20 to 30 yards apart, timed so that even if the first wave was stopped, the second would hit before defenders could fully reload or reposition. For an M2 gunner watching this develop through the darkness, the mathematics turned ugly fast. A kill zone 80 yards deep, which was typical for defensive positions in broken jungle terrain, could be crossed by advancing infantry in roughly 90 to 120 seconds. But Japanese forces didn't come in a single wave. They came in 3, 4, sometimes 5 successive waves, each separated by enough time that you couldn't ignore them, but not enough time to execute a proper barrel change. To stop a coordinated assault like this required sustained fire for at least 5 to 8 minutes. With standard barrel change doctrine, you had maybe 6 minutes of total firing time spread over 30 minutes of combat, accounting for barrel swaps and cooling periods. If the attack lasted longer than that, or if the intensity required continuous fire without pause, you faced an impossible choice. Keep firing and risk catastrophic barrel failure, or stop firing and surrender tactical initiative to an enemy who would use every second of your silence to close the distance. Corporal Anthony Stein encountered this exact dilemma on Henderson Ridge on the night of November 13, 1942. His position covered a natural draw between two hills, a corridor about 80 yards deep and 40 yards wide where vegetation thinned just enough to create a proper killing zone. Intelligence reports had indicated a major Japanese offensive was coming, and those reports were correct, though they failed to capture the scale. The entire 38th Infantry Division, fresh professional soldiers with combat experience in Manchuria and China, had been committed to breaking through the American defensive perimeter around Henderson Field. Stein's 3-man gun crew held a position that military analysts would later call textbook defensive terrain. Stein called it a death trap because if the Japanese came through that draw in force, his M2 would be the only thing preventing them from rolling up the entire right flank. The attack began at 02:30 hours on November 13th, with no artillery preparation and no warning. Just shapes moving in the darkness. Lots of them. Advancing with the kind of discipline that comes from professional soldiers who've trained together for years. Stein's assistant gunner, Private Eddie Morrison, spotted them first through the darkness and estimated at least 200 men forming up in the tree line, maybe more. They were carrying Bangalore torpedoes to breach wire obstacles, scaling ladders to cross defensive trenches, and enough small arms ammunition to sustain an assault for hours. Standard defensive doctrine called for short, controlled bursts, 5 to 7 rounds, then pause to assess. Conserve ammunition, prevent barrel overheating, maintain weapon reliability. But Stein could see what was developing in front of him, and controlled bursts weren't going to cut it. The Japanese were massing for exactly the kind of attack where they just kept coming, regardless of casualties, until they either broke through or ran out of men. If Stein fired in short bursts, enough Japanese soldiers would survive the crossing to overrun his position. Once they got past his gun, they'd be behind the defensive line, with nothing but scattered rifle squads between them and the airfield. Stein had 2 spare barrels stacked beside his position. Following doctrine, that gave him maybe 6 minutes of total firing time spread over 30 minutes of combat. His loader, Private First Class Jack Chen, had 12 ammunition cans stacked within arm's reach, 600 rounds ready to go with runners standing by to bring more. The ammunition wasn't the problem. Time was the problem. Stein was looking at an assault force that would require at least 8 to 10 minutes of sustained fire to stop, and he had equipment designed for 6 minutes maximum. The engineers at Colt's Patent Firearms Manufacturing Company, who produced most of the M2 barrels during World War II, used a steel alloy designated as SAE 4150. This chromium molybdenum steel was chosen specifically for its ability to withstand repeated thermal cycling and maintain structural integrity under stress. At room temperature, SAE 4150 had a tensile strength of approximately 125,000 pounds per square inch, which made it exceptionally resistant to the kind of pressure and heat that machine gun barrels endured. The manufacturing process involved gun drilling a solid steel billet, then rifling the interior with 4 grooves at a right-hand twist of 1 turn in 15 inches. The finished barrel went through a heat treatment process, heated to 1550 degrees Fahrenheit, quenched in oil, then tempered at 800 degrees. That process gave it a specific hardness rating of Rockwell C 28 to 32. Here's where material science became a matter of life and death. That heat treatment created a microstructure in the steel that could handle thermal stress up to a certain point, but steel's mechanical properties degrade in a predictable curve as temperature rises. At 600 degrees Fahrenheit, SAE 4150 steel retains about 90% of its room temperature strength. At 900 degrees, you're down to 70%. At 1100 degrees, you've lost half your strength. And at 1200 degrees Fahrenheit, the temperature that M2 barrels reached after about 150 to 180 seconds of sustained fire, the steel retained only 40% of its original tensile strength. The barrel was still solid metal, still looked normal to anyone who glanced at it, but it was structurally compromised in ways that could manifest instantly and catastrophically. The failure modes varied, but experienced gunners learned to recognize the warning signs if they knew what to watch for. First came accuracy degradation. As the barrel heated and expanded, the rifling grooves widened microscopically, causing the bullet to lose its stabilizing spin. Rounds that should group within a 6-inch circle at 100 yards started spreading to 18 or 24 inches. Tracers, which made up every 5th round in standard M2 ammunition belts, began drawing curved paths through the air instead of straight lines. Smart gunners watched their tracers religiously. When they started spiraling, you had maybe 20 seconds before serious problems began. Next came the headspace issue, and this is where things got dangerous fast. The headspace on an M2 was the gap between the bolt face and the base of the cartridge when the round was chambered, properly set at 0.063 inches, roughly the thickness of 2 sheets of paper. If it grew too much, the cartridge case wouldn't be properly supported when the firing pin struck. The primer would fire, pressure would build, and the unsupported brass case would rupture. Sometimes this just meant extraction failures and jams. Sometimes it meant hot gases and brass fragments venting back through the receiver into the gunner's face. The worst-case scenario was thermal runaway. At extreme temperatures, the chamber itself became hot enough to ignite the powder in a chambered round without the firing pin ever striking the primer. This cook-off would fire the round, chamber the next one, which would also cook off, creating a runaway gun that fired uncontrollably until the ammunition belt ran out. You couldn't stop it. The trigger became irrelevant. Your only option was to break the ammunition belt, and if you were in the middle of combat with enemy soldiers closing on your position, that might not be feasible or safe. Marine Corps after-action reports from Guadalcanal documented 23 separate instances of M2 barrel failures during the first 3 months of fighting. 7 resulted in complete barrel ruptures that destroyed the weapons. 4 caused serious injuries to gun crews, burns and shrapnel wounds that required medical evacuation. In one particularly grim incident on October 8, 1942, a cook-off killed a corporal from the 1st Battalion, 7th Marines, when the runaway gun traversed on its mount and swept rounds across his own position before anyone could break the belt. Anthony Peter Stein was 23 years old on November 13, 1942, which made him one of the older men in his squad. He'd grown up in Dayton, Ohio, where his father worked as a tool and die maker at National Cash Register Company. Tony followed his father into machining, spending 3 years learning precision metalwork before the war started. That background mattered more than anyone realized at the time, because Stein understood machines at an intuitive level that most 23-year-olds didn't. He knew what metal did under stress, had seen steel warp from heat, watched tolerances shift as components expanded, and learned how to work within or around those limitations. Stein had enlisted in the Marine Corps in January 1942, gone through boot camp at Paris Island, then received an assignment to the 1st Marine Division as a machine gunner. The Corps put him on the M2 specifically because of his mechanical aptitude. The weapons platoon sergeant took one look at his civilian work history and said, "You're on the 50. By November, he'd fired approximately 8,000 rounds through various M2s during training and combat. He knew the weapon's quirks, its strengths, and its limitations better than he knew his own rifle. Now he stood behind that weapon, watching, shapes multiply in the darkness, and his mind was working through calculations that had nothing to do with courage and everything to do with arithmetic. The kill zone in front of his position measured approximately 80 yards deep. Japanese infantry moving at a tactical advance pace through broken terrain would cover that distance in roughly 90 to 120 seconds. But they weren't coming in a single wave. Stein could see multiple lines forming up in the tree line. Standard Japanese assault doctrine called for successive waves, spaced about 20 yards apart. That spacing meant even if he stopped the first wave, the second would hit 30 seconds later, then the third, then the fourth. Morrison, his assistant gunner, had counted at least 200 men in the assembly area, probably closer to 250. Japanese infantry squads typically operated in 13-man sections, so they were looking at roughly 18 to 20 sections preparing to assault. Not all of them would come through Stein's kill zone. Some would hit other parts of the line, but at least half would come through here. Call it 100 to 125 men who needed to be stopped right here, right now, or they'd break through. The M2 fired 450 to 600 rounds per minute, depending on how you worked the trigger. Stein typically ran about 500 rounds per minute in combat, not the maximum cyclic rate but fast enough to be effective. To put 100 men down, assuming each man required an average of 4 to 5 rounds to guarantee a kill or disabling wound, he needed to put approximately 400 to 500 rounds downrange. At 500 rounds per minute, that was 50 to 60 seconds of trigger time, but that assumed perfect accuracy and no need for suppressive fire, which was fantasy. Real combat required at least double that amount, maybe 800 to 1,000 rounds total, to account for misses, suppression, and the reality that men don't always go down from a single hit. The math kept getting worse. 800 rounds at 500 rounds per minute meant 96 seconds of sustained fire. Add in the time needed to traverse the gun to engage targets across the entire width of the kill zone, and you were looking at 2 minutes minimum, but the Japanese were coming in waves, not all at once. The assault would last at least 5 minutes from first contact to the final enemy soldier either dead or driven back. To maintain effective fire throughout that 5-minute window, accounting for barrel changes, Stein would need to actually shoot for approximately 8 to 10 minutes total. He had 3 barrels. Standard procedure gave him 6 minutes of firing time spread over 30 minutes of combat. He was at least 2 minutes short, probably 4 minutes short if things went badly, and things always went badly. Stein made his decision in about 5 seconds, which is all the time he had before the Japanese started moving. What he did next would never appear in any official Marine Corps manual, would violate every technical bulletin ever written about the M2 Browning, and would be based on principles that any machinist who'd worked with cutting tools and metal fabrication would understand instinctively, even if every officer in the Corps would have court-martialed him for even suggesting it. The concept was evaporative cooling, the same physics that makes you feel cold when you step out of a swimming pool on a windy day. When liquid water converts to vapor, it absorbs an enormous amount of energy, approximately 540 calories per gram at sea level. This latent heat of vaporization is why sweating works as a cooling mechanism for your body, and why pouring water on hot pavement in summer makes that distinctive sizzling sound. Apply liquid to a superheated metal surface, and you create an extremely efficient heat transfer mechanism. The liquid absorbs thermal energy from the metal, converts to steam, and carries that energy away into the atmosphere as vapor. Industrial machining operations had used liquid cooling for decades by 1942. Cutting tools, drill bits, and milling machines all operated with constant coolant flow to prevent thermal damage to both the tool and the workpiece. The coolant was usually a mixture of water and soluble oil, carefully formulated to provide optimal heat transfer while also lubricating the cutting surface. But in emergency situations when coolant systems failed, machinists would use whatever liquid was available. Stein knew this from his days at the National Cash Register. He'd seen what happened when coolant pumps failed during high-speed operations. Tools overheated and failed within seconds, destroying both the cutting edge and sometimes the workpiece. He'd also seen experienced machinists jury-rig emergency cooling systems using whatever liquid was at hand, including some creative solutions that would never appear in official shop manuals, but worked well enough to finish a critical job. The problem with cooling an M2 barrel in combat was straightforward logistics. You needed liquid. You needed it immediately available within arm's reach, and you needed enough of it to make a difference against barrel temperatures exceeding 1,000 degrees Fahrenheit. Water was ideal from a pure thermodynamic standpoint. Its specific heat capacity and heat of vaporization made it one of the most effective cooling fluids available. But water was precious on Guadalcanal. Canteens were for drinking, not wasting on weapons. Bringing water cans up to a forward fighting position just for the purpose of cooling a gun barrel would require you to explain yourself to every officer between here and division headquarters. Besides, in the middle of a night assault with Japanese soldiers advancing through the darkness, you used what you had within immediate reach. What Stein had within arm's reach was urine. His own, Morrison's, Chen's, and that of any other Marine in the immediate area who could contribute to the supply. Human urine is approximately 95% water, with the remaining 5% being dissolved urea, creatinine, uric acid, and various mineral salts. From a heat transfer perspective, it's almost as effective as pure water. The dissolved solutes actually raise the boiling point slightly above that of pure water. Pure water boils at 212 degrees Fahrenheit at sea level, while urine boils at around 214 to 215 degrees due to the dissolved compounds. But at barrel temperatures exceeding 1,100 degrees, that 2 or 3 degree difference was completely irrelevant. The liquid would flash to steam almost instantly, regardless of its exact composition. The chemical composition did create some potential complications that Stein understood from his machining background. Urea decomposes at high temperatures into ammonia and carbon dioxide, which meant the process would produce a distinctly unpleasant smell. The dissolved mineral salts could theoretically leave residue deposits on the barrel surface or even inside the bore, though at the temperatures involved, most organic compounds would simply combust and vaporize rather than accumulating. The uric acid might cause minor corrosion issues over extended time periods, attacking the steel surface in ways that pure water wouldn't. But those were problems for tomorrow. Problems for the armourers who would inspect the weapon after combat. Today's problem was keeping the barrel cool enough to fire continuously for 8 to 10 minutes without catastrophic failure. Core regulations explicitly prohibited what Stein was about to do, though the specific wording was buried in Technical Manual TM 91005213 under a section titled Unauthorized Cooling Methods. The manual stated clearly, under no circumstances should gunners attempt to cool barrels using non-approved liquids, including seawater, alcohol, petroleum products, or bodily fluids. Such practices may cause permanent damage to barrel surfaces and create unsafe operating conditions. The regulation existed because previous wars had taught the army that soldiers would try anything in desperation, and some of those improvised solutions made situations worse rather than better. Seawater caused severe corrosion. Alcohol could ignite. Petroleum products created toxic fumes and fire hazards. Stein didn't care about regulations. He cared about math, physics, and the 200 Japanese soldiers who were about to rush his position. He cared about the Marines positioned behind him who were depending on his gun to hold this section of the line. He cared about Henderson Field, which meant he cared about controlling the only operational airstrip in the Solomon Islands, which meant he cared about who would win the Pacific War. Regulations could be sorted out later, assuming anyone survived long enough to file paperwork. The first burst went out at 02:37 hours. 35 rounds that cut through the lead Japanese section like a saw through bamboo. Stein worked the trigger in controlled patterns, letting muscle memory guide the traversing and elevation controls, while his conscious mind tracked a different problem. He had maybe 90 seconds before the first barrel change. Morrison already had one of the empty ammunition cans positioned next to the gun, and both he and Chen knew what was about to happen because Stein had explained it in about 15 seconds of whispered instructions that probably violated 3 or 4 articles of military justice. The Japanese kept coming. They had to. Once you commit to a night assault with several hundred men, there's no calling it off halfway through. The momentum of that many soldiers moving forward creates its own tactical reality. The second wave was already advancing, before the first wave's survivors hit the dirt. Stein put another 40 rounds into the mass of advancing soldiers, walking the fire from left to right across the width of the kill zone. The muzzle flash lit up the night like a strobe light, completely destroying his night vision but illuminating targets with perfect clarity during each half-second interval. He could see faces in those flashes, young faces, determined faces, terrified faces. Men who'd been told this was the breakthrough attack that would change the course of the war. He kept firing. At 92 seconds, the barrel was approaching critical temperature. Stein could feel the heat radiating from the weapon even through the standard firing position with his body offset from the receiver. The tracers were starting to spiral slightly, that telltale sign that the rifling was losing its grip on the bullets as the grooves expanded from thermal stress. He yelled, "Barrel!" over the gun's hammering, and Morrison already had his. Hands on the barrel release mechanism. Standard barrel change procedure required the gunner to lift the barrel locking pin, rotate it 90 degrees, then withdraw the barrel to the rear, while the assistant gunner prepared to insert the replacement. Morrison had practiced this procedure approximately 1,000 times between training and combat. He executed it in 12 seconds, which was excellent time under the circumstances. Chen was ready with the ammunition can, not the full one with linked rounds, but the empty one they'd prepared for this exact purpose. Stein grabbed the hot barrel from Morrison and held it horizontal at waist level. Chen poured the contents of the can directly onto the steel surface. The effect was instantaneous and dramatic. The liquid hit metal that was somewhere north of 1,000 degrees Fahrenheit and converted to steam so fast it created a sound like a pressure cooker venting all at once. The cloud of vapor that erupted from the barrel was thick, white, and smelled exactly like you'd expect superheated urine to smell. Stein rotated the barrel continuously, letting Chen hit every side of the steel tube, ensuring even cooling across the entire circumference. The steam cloud grew thicker, briefly obscuring the entire gun position in a fog that smelled of ammonia and scorched metal. The entire cooling process took maybe 8 seconds. Steam was still rising from the barrel in wisps when Morrison slammed the fresh barrel into place and locked it down with movement so practiced They were almost automatic. Total weapon downtime, 20 seconds. Stein was back on the trigger before the steam cloud had fully dissipated, firing into the second wave that had used those 20 seconds to advance another 15 yards closer to his position. He burned through another 80 rounds in the next 90 seconds, watching the Japanese ranks thin but not break. They were committed with the kind of determination that comes from professional soldiers who believe in their mission. Command had probably told them this was the decisive attack, the breakthrough that would retake Henderson Field and shift the entire strategic balance in the Solomon Islands. They believed it enough to keep coming even as bodies piled up in the kill zone. The smell was atrocious. Ammonia from the decomposing urea mixed with cordite smoke from the gunpowder and the metallic tang of vaporized steel particles created an atmosphere that would make you gag if you weren't too busy trying to stay alive. Stein's eyes were watering, partly from the chemical assault on his sinuses and partly from the smoke and continuous muzzle flash. He didn't care. The gun was still firing, still putting rounds on target with acceptable accuracy, and that was literally the only thing that mattered in this moment. At 4 minutes into the engagement, Stein was on his second barrel change. The first cooled barrel had been sitting for 3 minutes and had dropped enough in temperature to be theoretically safe to reinstall. Chen hit it with another round of liquid cooling as insurance before Morrison installed it, producing another cloud of steam that briefly obscured the entire position. The Japanese soldiers advancing through the darkness must have seen those periodic steam clouds rising from the American defensive line and wondered what kind of weapon the Marines had deployed. The clouds appeared every 90 seconds like clockwork, each one accompanied by a brief pause in the devastating fire that was tearing apart their assault formations. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The engagement lasted 9 minutes and 40 seconds from first shot to last. Stein fired 847 rounds total, rotating through his 3 barrels, 4 complete cycles, with Chen performing emergency liquid cooling on each barrel twice during the sequence. The gun never jammed, never misfired, never failed. The barrels showed discoloration and surface staining from the chemical residue, but they maintained structural integrity throughout the engagement. When the last Japanese soldier either fell or retreated back into the jungle darkness, Stein's hands were shaking so badly he couldn't light a cigarette. Morrison had to do it for him, his own hands none too steady. The sun came up 6 hours later and revealed what they'd accomplished. Bodies were stacked in overlapping rows across the kill zone, thickest at about 40 yards out, where the second and third waves had collided with the first wave's casualties, and the advancing soldiers had been forced to literally climb over their dead comrades to continue the attack. The division's Graves Registration Unit spent 2 days cataloguing the dead in front of Stein's position. Official count: 73 confirmed enemy, killed in action directly attributable to the M2 position on Henderson Ridge. Another 15 to 20 probable kills where blood trails led back into the jungle, but no bodies were recovered. Captured Japanese soldiers from the 38th Division, interrogated over the following weeks, reported that their officers had specifically identified Stein's gun position as the intended breakthrough point. The tactical plan had assumed they could overwhelm a single machine gun position through sheer numerical superiority and sustained pressure. The Japanese commanders understood that American doctrine required barrel changes every 90 seconds, creating predictable windows of vulnerability. They'd timed their assault waves to exploit those windows, expecting each pause in fire to allow another wave to close distance. They'd been wrong. Lieutenant Colonel Lewis Burwell Puller, commanding the 1st Battalion, 7th Marines, walked the position at 0800 hours. Chesty Puller was already a legend in the Corps at age 44, 2 Navy Crosses, earned in Nicaragua during the Banana Wars, a reputation for being absolutely fearless under fire, and a command style that mixed rigid professionalism with a complete disregard for anything that didn't directly contribute to winning battles. He looked at the body count spread across the kill zone, looked at Stein's M2 still mounted in its firing position, then looked at the empty ammunition cans sitting beside the position. One of them still had liquid pooled in the bottom. Puller stuck his finger in the liquid, sniffed it, and his expression didn't change at all. He looked at Stein and said something that has appeared in at least 6 different versions in various historical accounts, each one claiming to be the authentic quote. The printable version that appears in most official histories is, "Corporal, what in the name of God is this?" Stein told him everything. The thermal calculations based on his machining experience, the evaporative cooling principle he'd learned working with cutting tools, the emergency barrel cooling procedure that had kept the gun firing for nearly 10 minutes straight, without catastrophic failure. Puller listened with his face completely neutral while Morrison and Chen stood at attention nearby, both men expecting to be arrested on the spot for violating regulations during combat. When Stein finished his explanation, Puller walked over to the M2 and ran his hand along the barrel that was still mounted in the weapon. He noticed something interesting. The barrel showed obvious discoloration, dark patches where the steel had been repeatedly superheated and then rapidly cooled. There was surface staining from chemical residue that would require serious cleaning to remove, but there was no warping, no visible cracks, no signs of the catastrophic structural failure that should have occurred according to every technical manual ever written about sustained fire with the M2 Browning. What happened next depends on which historical account you believe, and the Marine Corps archives contain at least 3 contradictory versions. Some sources claim Puller immediately put Stein in for a Silver Star, recognizing that extraordinary circumstances had required extraordinary initiative. Other accounts say Puller filed a formal report that triggered an investigation by Division Ordnance, covering himself against potential accusations that he'd condoned regulatory violations. What's actually documented in the 1st Marine Division records, available now at the National Archives, is that on November 15, 1942, Lieutenant Colonel Puller submitted a commendation report citing extraordinary initiative and technical innovation under combat conditions for Corporal Anthony Stein. That commendation worked its way up the chain of command and eventually became a Bronze Star recommendation, which was subsequently upgraded to a Silver Star by Major General Alexander Archer Vandergrift himself, the commanding general of the 1st Marine Division. The citation praised Stein's exceptional courage and resourcefulness in maintaining continuous fire during a critical defensive action, though it carefully avoided mentioning the specific method used to achieve that, continuous fire. But the Marine Corps was also institutionally horrified by what had happened. Within 1 week of Puller's report reaching division headquarters, Stein was summoned to appear before a panel that included 2 lieutenant colonels from the Ordnance Section and a major from the Judge Advocate General's office. The JAG officer made it very clear that unauthorized modifications to weapons procedures violated Article 92 of the Articles of War, failure to obey lawful orders or regulations. The penalty for such violations ranged from reduction in rank to dishonorable discharge, depending on circumstances and command discretion. The ordnance officers, however, wanted details. They weren't interested in prosecuting Stein. They wanted to understand exactly what he'd done and whether it represented a viable solution to a tactical problem that was getting Marines killed across the Pacific Theater. They brought a demonstration M2 to the meeting, along with a chronograph to measure muzzle velocity and enough ammunition to run actual controlled tests. They made Stein repeat his cooling procedure 6 times, while they measured barrel temperature before and after treatment, documented timing, and assessed the effectiveness of the technique under various conditions. The test results from that November 1942 demonstration were classified as restricted and filed in Ordnance Report O-421173, which wasn't declassified until 1967, a full 25 years after the events occurred. What those tests revealed contradicted 2 decades of accepted doctrine about barrel cooling and thermal management in heavy machine guns. The ordnance officers measured barrel temperature before and after Stein's liquid cooling method, using thermocouple probes inserted into test ports, drilled into sample barrels. A barrel at 1,150 degrees Fahrenheit dropped to 680 degrees in approximately 15 seconds when treated with Stein's technique. Air cooling, that same barrel, from 1,150 degrees to 680 degrees required 7 minutes and 20 seconds under optimal conditions, with the barrel removed from the weapon and positioned for maximum. airflow. The liquid cooling method was roughly 29 times faster than air cooling. The chemical analysis of the technique produced mixed results that the ordnance officers documented carefully. Yes, the urea decomposition created ammonia vapor that was unpleasant and potentially hazardous in enclosed spaces, though in open-air combat positions this posed minimal health risk. Yes, the dissolved mineral salts in urine left microscopic deposits both on the provet, barrel's exterior surface, and potentially inside the bore itself, deposits that could theoretically affect accuracy after repeated applications. The uric acid and other organic compounds did create minor surface corrosion that wouldn't occur with pure water cooling. But here's what mattered. The barrels didn't warp from the thermal shock of rapid cooling. They didn't crack or develop structural flaws. They didn't fail catastrophically. The rapid temperature drop created thermal shock, a sudden contraction of the steel that in theory should have caused problems. But SAE 4150 chromium molybdenum steel proved resilient enough to handle this stress. After 6 complete cooling cycles in the test sequence, the sample barrel showed 0.03 inches of measurable wear beyond normal firing wear, which was well within acceptable tolerances for a combat weapon. The Marine Corps faced an institutional dilemma that would have been comedic if it weren't so serious. They couldn't officially endorse urinating on machine guns. The optics were terrible from a public relations standpoint. The health concerns, while minimal in practice, created potential liability issues. And imagine trying to explain that procedure to Congress during appropriations hearings or to the press corps that covered the war. Yes, Senator, we've discovered that our Marines can dramatically improve weapons performance by urinating on their machine guns during combat. It would become a joke, reduce a legitimate tactical innovation to something that sounded absurd. But they also couldn't ignore the results. Stein had achieved something that shouldn't have been possible according to every technical manual and engineering analysis: sustained fire that exceeded the weapon's theoretical thermal limits by more than 60% without catastrophic failure. He'd maintained effective fire for 9 minutes and 40 seconds using a weapon designed for 6 minutes maximum with barrel changes. And he'd done it using nothing but basic thermodynamic principles and available materials. The solution the Marine Corps adopted was typically bureaucratic and, in its own way, quite pragmatic. They didn't approve the technique officially. They didn't add it to training manuals or technical bulletins. But they also didn't court-martial anyone for using it. The incident was quietly noted in training materials as an example of unauthorized field modifications that, while effective in specific circumstances, remain prohibited under standard operating procedures. The message was clear. We saw what you did. We understand why you did it. Don't do it again unless you absolutely have to, and if you do have to, we didn't tell you to. What changed immediately was the official doctrine around spare barrels and barrel-changing procedures. Pre-Guadalcanal, most M2 positions in the Pacific carried 1 spare barrel as standard issue. Post-Guadalcanal, after Stein's action and similar incidents at other defensive positions, the standard load increased to 2 spare barrels minimum, 3 when logistics allowed. The emphasis on barrel-changing speed increased dramatically in training. Training cycles that had previously allocated 2 hours total to barrel-changing drills expanded to 8 hours, with Marines practicing the procedure blindfolded, in gas masks, under simulated fire, and in various states of exhaustion, until they could execute a complete barrel change in under 20 seconds consistently. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.